right. So new unit, unit 4, and this is on the lithosphere. Okay, so we're going to talk about the different types of rocks, and we're going to talk about the rock cycle. So the first one we're going to talk about is the igneous rock. Okay, so igneous rocks, okay, there are different types of igneous rocks. So the first we're going to talk about are how they form. Igneous rocks are formed by the cooling of liquid rock. So two things that will determine which igneous rock: how fast it cools and the composition of the actual melted rock. So composition, I'm talking about what it's made up of. Okay? The next thing we need to understand is the difference between magma and lava. So if you see, it says extrusive lava. So lava is what actually comes out of the volcano, whereas magma is found inside. So once that magma starts coming out, that's when it would become lava. So the types are intrusive and extrusive. So when you hear the word in, you're going extrusive, out, okay? So igneous rocks can either form deep within the earth or near or on the surface. Okay, so intrusive igneous rocks form deep beneath the surface. So think inside, intrusive inside. And they have been cooling for millions of years. So these rocks are characterized by large crystals, and a great example of an intrusive igneous rock is granite. So a lot of times you might see some houses have like a granite countertop. Okay, this is granite. Next is extrusive. So extrusive igneous rocks form on the surface of the earth. So intrusive inside, extrusive on the surface. So when the lava erupts out of a volcano, it cools rapidly and there is little to no crystal growth. So an example of this would be an obsidian or pumice. Anybody ever heard of a pumice stone? A lot of times you might use that to get the dead skin off. You know what I'm talking about? Okay. And then this one up at the top, this dark black color is like a deep black is your obsidian. Okay. So the texture of an igneous rock. So texture, we're talking about what it feels like, right? So texture deals with, in this case, the big crystals in the igneous rock, okay? So there are 4: coarse-grained, porphyritic, fine-grained, and glassy. So something that is coarse-grained is going to have large crystals and slow cooling. So if something is coarse, okay, and you were to touch something that's coarse, what does it feel like? It's coarse. Kind of what? Is it smooth? Is it rough? Something that's coarse. Smooth or rough? What do you think? Rough. Something that's a little bit more rough. Because then if you were going to look down at the bottom, something that's glassy, there are no crystals, and this instantly cools. So something that's glassy, if you were to touch it, is going to be what? That's going to be smooth, okay? So in the middle, we've got porphyritic and fine-grained. So porphyritic, both large and small crystals. So these slow cooling with different minerals. And the fine-grained are small crystals. Those also cool fast. Okay, so coarse-grained are large, porphyritic, both large and small, fine-grained are small, and glassy, there are none. Okay, so think at the top, we're definitely rougher here because the crystals are bigger, and then when we get to the bottom here with glassy, it gets a lot more smooth. So here are some pictures of different types of igneous rock. Next is the composition. So when we talk composition, we're talking about what it's made up of. So the composition deals with the chemical makeup of the rock. So silicates are the most common minerals on Earth. So we've got felsic, andesitic, mafic, and ultramafic. Okay, so felsic is light. So this rock is made up mostly of silicates, over 65% silica. Andesitic is medium. So this rock is half dark, half light. So 55 to 65% silica. Mafic is much more dark. So this rock is rich in iron and magnesium. So 45 to 55% silica. And last is ultramafic. And these rocks are also rich in iron and magnesium. These are under 45% silica. Okay, so note we go from light to dark. So if mafic is dark, and we talk about ultramafic, okay, those are also going to be dark. So here are some pictures. Next, we're going to get into sedimentary rocks. Sedimentary rocks are made from an accumulation of various types of sediment, okay? So what is sediment? Sediment are fragments that result from the breaking or weathering of rocks, minerals, and organic matter. So for example, gravel, clay, silt, pebbles, sand, mud, shells, and dirt. So most sedimentary rock forms under water. So for example, limestone and halite. So sedimentary rocks form from these processes. So we've already mentioned weathering. Okay, so weathering, erosion, and deposition. Next is compaction. So sediments are pushed together, and then as a result, water and air become squeezed out. Because if you were to take something and squeeze it together, you are squeezing out all the water and air. Next is cementation. So water passes through the sediments and dissolved minerals left behind act as a cement to hold the sediments together. Precipitation, minerals clump together and fall out of the solution. And last is evaporation. So water evaporates and leaves dissolved minerals behind. Okay. So there are three types of sedimentary rocks. The first is clastic. Clastic is formed from fragments of other rocks which have been weathered and eroded. They are classified by the size of the sediment. So coarse pebbles are larger, medium sand sized, or fine clay or silt sized. So pebbles, then we go down, okay, sand sized, and then to clay or silt. So an example of this would be sandstone, shale, conglomerate, and breccia. Okay, those are some examples. So sandstone, sand, shale, silt, or clay. Conglomerate are round pebbles, and the breccia are angular pieces. Next is chemical. Chemicals form from minerals that were once dissolved in water. So either the minerals settle out of the water or the water evaporates, leaving the minerals behind. So they are either called precipitates or evaporites. So these are classified by their mineral composition. So for example, chemical, limestone, gypsum, or halite. And then the last one is organic, okay? Organic is formed from the remains or traces of animals and or plants. So for example, coal, where I'm from, coal is a big thing up north. Chalk and organic limestone. So some features of sedimentary rocks include stratification. So this is how they are layered. So if you look up here at this picture, you could see the different layers, okay? So this occurs when there's a change in the kind of sediment that is deposited. So for example, what you see would be like the Grand Canyon. Anybody ever been? Next are ripple marks. So these are formed from the action of wind or water on sand. Okay, and this is obviously seen in sandstone. So you can see this in the picture below. Next is fossils, and fossils are the remains of something that was once living. So remains are traces of plants and or animals. So we can find fossils within a rock. All right, and the last type we're going to talk about is metamorphic. Okay, rock that is formed from other rocks. Metamorphic rocks are formed from other rocks. So they are formed from igneous, sedimentary, or metamorphic as a result of intense heat and pressure. So the key words here are intense heat and pressure. So most metamorphic rocks form below the surface of the earth. So there are two ways that they can form. First is contact metamorphism. So this occurs when hot magma pushes through existing rock and changes the structure and composition of the surrounding rock. So the original minerals may form larger crystals. So when we're talking larger, we're coarse, okay? This is rough. And then second is regional metamorphism. This occurs when tectonic plates, and we're going to get into plate boundaries, push against each other, causing heat and pressure that chemically changes the minerals of the rock. So most metamorphic rock is formed this way. So most is regional, not so much contact. So they're also classified according to their structure. So what they look like. So there is foliated metamorphic rock. So this pressure flattens the mineral crystals and pushes them into parallel bands. So minerals with different densities separate into different bands. So for example, slate, schist, and gneiss. So up here, you have a picture of slate, schist, and gneiss. Next is non-foliated. So this is going to be opposite. So there are no visible parallel bands. So quartzite and marble are examples of this. And then there's what is known as a parent rock. A parent rock is the rock from which a metamorphic rock is actually formed. So marble formed from limestone, slate from shale, gneiss from granite, schist from slate, quartzite from quartz, quartzite from sandstone, soapstone from talc, and schist from gneiss. So note that you see some of them on one side and the other because metamorphic rocks are formed from another rock, whether it is sedimentary, metamorphic, or igneous. So this brings everything together in what is known as the rock cycle. And a cycle does what? It starts all over. So everything is connected and intertwined, and it's an ongoing process. Okay, so rock materials are constantly being recycled, and each rock type can become a different type in its journey through the rock cycle. Okay, so energy that drives the rock cycle are both heat and mechanical. So those are the two types of energy that drive this particular cycle. So up here you can see a picture of the rock cycle, and you are going to do some activities involving the rock cycle. So you see some of the things we talked about, weathering, okay? You see all the different types of rock here, metamorphic, sedimentary, igneous. And when you look at, I know it's got a lot of colors going on, and it will probably be easier for you to see on your own computer. But if you look all of the arrows go to each type of rock. So you're gonna see igneous, okay? You've got igneous rock, weathering, and then you have sedimentary rock. Okay, the sedimentary rock into metamorphic. But then you've got igneous, if you look, can go to what? Metamorphic, right? So they're all interconnected. Does everybody see that? Yes? Okay, so the rock cycle is completely intertwined. And at the end of the day, all rocks can be formed in some way, shape, or form from each other. So during the rock cycle, there is a cycling of materials. So there's formation and destruction of the three major rock types. The forces that are responsible for this are the following. So weathering and erosion, which creates sediment. Deposition and bedding, so the sediment is deposited. Heat and pressure, these are what transform the parent rock. Foliation, minerals pushed into bands, so those where we see the different banding patterns. And last is melting, which turns material into magma or lava. So magma inside, lava out.